You're listening to ChainLeak, the crypto news podcast with your host, Joshua Roomsberg. Follow and subscribe today.
Welcome to the ChainLeak podcast. I'm your host, Joshua Roomsberg. Today's episode is about Syscoin, the ZK bridge for Bitcoin. Today's guest, Jag, the lead developer for Syscoin. Welcome to the show, brother.
Hey man, how you doing? Thanks for having me again.
I'm good. I appreciate you taking the time.
No problem.
So for the listeners who are not aware of Syscoin or are not familiar to the ecosystem, give them a quick breakdown of what you guys have been doing for the last 10 years.
Yeah, we were one of the very first altcoins that existed. I played around with a bunch of them like Namecoin, Devcoin, IX coin, and a few of the very, very first, like first 3 or 4 coins to get familiar with doing more than just like first I was in Bitcoin and looking at other stuff to see if we could do more, given the strict nature of the stack in Bitcoin, right? You can't do like Turing complete stuff, and I think it's not supposed to, and it's good. I was on like a little Spaces today, and we covered that, right? The ossification of Bitcoin. I think it's important to understand the rigid nature and the utility function that Bitcoin presents is a high utility for transfer, and that is its killer app, right? It's not moving around money at lightning speeds. It's holding that money so it doesn't wither away over time, and people value that much more than just doing e-commerce. E-commerce can be built on top. So we, for us, we're like, can we do commerce around Bitcoin in some meaningful way? So we started with merge mining, thinking that, okay, well, one day we'll have bridges. It's just right now they're federated and nothing's really useful. It's just not for us as a decentralized project. So we'll keep going and see that in the future. So we focus more on securing alternate ledger with Bitcoin's hash rate, and merge mining was one of the first things, and then doing assets and NFTs and all this sort of stuff was presented, and we kept creating what features came to be on Ethereum, and then we streamlined by taking them out, and in the end we ended up with a general EVM dual chain, having the best of both. You have the UTXO side, which is mined with Bitcoin. It has a data availability layer to scale up the rollups, which are settled on the EVM side. The EVM side is purposefully a settlement layer, so it's not meant to be fast. It's not meant to be abundant. It's meant to be really easy for nodes to sync up quickly and efficiently and in a decentralized way. And then the rollups built on top. So that's what we did up until a couple of years ago, and we started looking at ZK and making sure that on the edges, the computing could happen in a scalable way. The final pieces was the connection finally to bring Bitcoin over isn't possible to do in a secure way. That's what the ZK bridge is about.
Let me stop you there. For Syscoin to be merge mined with Bitcoin, and then you have the EVM layer, how does the Syscoin move between chains? Is that where the bridge comes in hand, or is it something else?
Yeah, so we have a native layer between UTXO where the Bitcoin miners are mining SYS, and if you want to move your SYS over to the virtual machine, there's a native protocol bridge that mints and burns on both sides, and it's built into the protocol. For Bitcoin, you can't have a built-in bridge, right? Because Bitcoin doesn't understand bridging, and even if you have a ZK, like people are saying, if you have a ZK verifier in Bitcoin, everything's solved. It's not, because you can't build an ossified bridge into Bitcoin. Like you don't even have ossified bridges in Ethereum. The rollups, those are managed treasuries or managed multisigs or corruptible DAOs, in some way.
Yeah.
So those are never going to be really ossified, but you can get, pretty good, and to a point where you have templates of bridges that seem to make sense and you run with those. You won't standardize on a bridge. And the second part is Bitcoin doesn't have the data bandwidth to store everything, to scale a roll-up centric model in a real efficient way. You can't store, you're going back square one, and going from maybe 7 transactions a second to maybe 50 transactions a second. It's
Now
not really.
with Syscoin in comparison to Bitcoin, when you talk about the amount of data that can be stored in a hash, is Syscoin superior to Bitcoin in that aspect when it comes to the size?
Well, we have 4 times more bandwidth in the native block. So
Okay.
our blockchain is 2.5 minutes instead of 10 minutes. The difficulty curve is identical, but it does target up and down a little bit quicker because of the faster time. And ramping down is a little bit different because it's merge mined. We don't want to have a situation where the miners jump off and then it takes forever to create another block.
Right.
So that was slightly tweaked for security reasons. But overall, the goal is not to use that data, but use ephemeral data that is going to live short term, just so that you can solve what's called the fisherman's problem. That dilemma is when you're a roll-up sequencer and you're going to sequence the next block, and then you withhold a little bit of byte of data, and you tell like for example, if a ZK verifier was in Bitcoin and you're doing a roll-up transition and you're saying these millions of transactions have happened in the last 2 hours, I'm going to crunch them up into a ZK proof and put that on Bitcoin. And that represents everything, including withdrawals and deposits and stuff that happen with actual Bitcoin on that side system, right? Now,
Yeah.
as soon as you do that, how do you know that ZK proof is just one hash? How do you know that you have what you need as a user to be able to exit that system without the help of someone else? You know, and that a fisherman's dilemma is that the sequencer purposefully may hold back a byte of data and tell the world, here's a ZK proof. The ZK proof has to be valid, but he doesn't expose the data to the world. He just holds it himself. So
Right.
the DA problem quickly comes in where you have to prove that the data exists somewhere, and you usually have to do it on the same chain. You have to say, here, the data exists, plus here's a ZK proof. You put those two together, and now you have a state transition for some external system that's settling on your blockchain. Why is that needed? Because the internet scaled up through edge computing, and every form of scale in humanity has always been through separation of concerns. You don't have one single place with all the computations happening. It's got to be split
Right.
up. So that's what rollups are. And if you don't solve the D problem, you can't scale. So Bitcoin can't really solve that. It's not in its design philosophy. Ethereum solves that, but it's proof of stake. We solve it, and we're proof of work. And we're solving it a little bit differently than what Ethereum does.
That was the next question for the scalability of Bitcoin in comparison to Syscoin. Moving the Syscoin transactions onto a rollup, is that more beneficial than anything that Bitcoin could do as far as scalability?
Yeah, I mean, like they have Lightning networks today, but you can't
Yep.
really. There is a flood and loot attack and other attacks that you can't get around because there's no consensus. You can't. Um, there is no logical proof that proves that all balances are correct. It's a state channel system. So if we're in a payment channel and I
Yep.
am moving around my Bitcoin with you, I'm signing an offline message and saying, yes, this is my current state. Next, I'm going to send you my balance. Now you're going to hold that state. But on the other hand, I could just go to the blockchain and say, this is the right state. It's up to you to say
Without
no.
even verifying it. That's wild. I didn't even
Yeah,
know that was possible.
it's up to you within a time lock to go into Bitcoin and say, hey, no, I have a later state that he signed over to me. And this is the
Wow.
right one, right? He signed this, therefore it's valid. But if you don't hit the time lock, you lose your funds, right? So the flood and loot attack is you can do this at a massive scale and force people to go hit the chain where it's going to cost them more money than would they just lose. And
Holy
done at
smokes.
scale, you can execute this profitably, right? That's what the papers are showing. So if you don't have consensus and you don't have a system where you can prove state all encompassing,
Yep.
then you end up having these problems. And if you have this state, then you're talking about a roll up. You're talking about a ZK virtual machine or a separate blockchain that's settling on Bitcoin. And there's various ways to sort. There's people are putting the state in Bitcoin, and somehow bridging. There's like Stacks is doing a miner integration, so you burn Bitcoin, you mint Stacks, and then you sort of burn
Okay.
the Stacks and get the Bitcoin in a different way. And then Risk is doing like functionaries, which are hardware secure devices, so it's putting your security in hardware or like a large multisig. We are not happy with any of those. We try to see, like, can we do better? Um,
Right.
like a federation model or trusted hardware is not good enough. Can we, like, the best we could do right now, we think, is trust minimize, so one of n, and that is a pretty good security assumption as long as there's enough n. It's good enough. It's pretty good.
Okay.
It's the best we can do right now, and that's what like BitVM and these other bridges are all about. Once you bring that Bitcoin, yeah, you would throw it in a roll-up model, because those roll-ups are meant to be much more scalable. They use the data availability of something like Syscoin, and they can scale to thousands of transactions a second. You could
Right.
pay minimal fees, and you could do your borrowing, lending, and stack sats on there more efficiently.
Okay. So when you think about UTXO, the base layer for Syscoin, and then you guys have the NEVM, the EVM layer for Syscoin, what are the biggest benefits of each version of the chain?
Yeah, UTXO has so many benefits, right? Like every time you check a transfer, you're basically moving your whole balance over to another state, and then you're storing the new state. While in the account-based model, like virtual machine and Ethereum, it's just like a bank account, and you're in and
Yeah.
out. UTXO can make it much more parallel, it's more scalable, but there's a whole track of Bitcoin that we have undiscovered. Maybe with OpCat and some of these new opcodes coming in Bitcoin, we can enable them on this coin as well, and they will enable us to do maybe new things that are not possible. Cardano's EUTXO, right? They built their whole value proposition based on the fact that you could do smart contracts in a much more efficient way on UTXO compared to account-based.
Okay.
Fuel VM, which is like a popular ZK-Rollup, is like a UTXO-based rollup that settles on Ethereum, but you go on there and it's super scalable because the proving can be all parallelized, and you can store your own proofs. Maybe you don't even have the DA problem because you're storing your own proofs and state. That's all possible with UTXO. And like, for example, with your MetaMask, you stored all your state, and if you're going to use a UTXO model, you could possibly make it so that you don't ever touch the blockchain. You don't need the DA. You can scale infinitely. You just prove on your local computer that your transaction is valid, and you send it to the blockchain. With the
Okay.
account-based model, it's much easier. Comes with limitations, but things like um, shared accounting, like DEXs and smart contracts and DAOs and stuff,
Yeah.
where you're sending funds and then you're extracting funds. There's shared accounting financial systems built into that. And when someone sends you funds, you want to prevent you having to redo all this work to prove it again. It also creates attack vectors, right? Um, and the account-based model solves that, and they use like an incremented number called nonce to know. So when you prove your state, you have to prove that you're signing off on your own money, but it's a global sort of balance.
Sign
And
off.
yeah, you're digitally signing that I have 15 coins and I'm going to move them to someone else. I have to sign off on that, but that's like a global bank account style uh, ledger, right? And then you also have to the system has to say, okay, Bob has taken 15 and put them to Tom, and has to record that in the DA layer so that later you can reproduce the state to say, yeah, Bob did move to
And
Tom,
it's
therefore
verified.
Tom has 15. So if tomorrow anyone wants to go back to Ethereum or the base layer, you would know that Tom has 15. You can make a proof for that. So it's a little bit different, but the UTXO whole design philosophy is underdiscovered, and I think that design space is open to more innovation. We want to keep both to see where they go.
Okay. Now, in addition to the EVM version of Syscoin, you guys also released Rollux. Now, was that last year or 2 years ago?
Yeah, a couple of years ago, and
Okay.
that
Now,
was like
what's the comparison between the three versions when you include Rollux now? I guess it
yeah,
would be more so with the EVM version, right?
right, because that's where all the fun was happening, right? The UTXO,
Yep.
again, undiscovered design space. There was no real proper way to do smart contracting, dexes, and that sort of stuff was really hard. NFTs, assets, there's no standardization. We tried to we tried to do standard tokens on the UTXO, but they were very hard to use, hard to do wallets, and the Cardano
Okay.
devs can definitely sympathize on that. While in the EVM, it was easy, right? Tooling is all there. And yeah, okay, it's not as scalable as a UTXO, but you don't need to scale like on one layer, right? So what we did was we said, okay, well, the EVM, let's just keep it really low gas limits and 2.5 minute block times so that every node, all of our Sentry nodes, we call them, they can all sync up and not require $100 a month or $500 a month, right? It's
Yeah.
decentralized. And we said, okay, well, let's create a DA layer and then do a roll up on top to prove that this model works. This modular approach works with Bitcoin securing all this. And that's what Rollux was. We created the first optimistic roll up secured by that DA layer that's mined alongside Bitcoin. And that is 2 second block time. So it's like instant. It's much easier to use. And you can send and receive, and it's like way cheaper because the DA
Right.
layer is cheaper, so
Yep.
it's more abundant. So that's and now that's transitioning to a ZK stack, and you get other benefits when you do ZK. It comes at a higher cost, but the ZK proofs are pretty efficient now. Like you could do hundreds or thousands of proofs per second in a block,
Okay.
and those proofs are getting more and more efficient. So we thought it's the right time.
Moving away from the different layers of Syscoin, you guys also recently launched BitVM 2. Can we talk about that a little bit and what that entails?
Yeah, BitVM two was a public sort of paper of ideation of how to do trust minimized bridging with Bitcoin and vaulting
Okay.
with Bitcoin, right? Like how you could you have a eureka moment on BitVM which shows you can run smart contract on Bitcoin using existing stack, right? And that meant you could do limited things like a vault. You don't want to do NFTs and all this crazy stuff, but you might use it for a vault because a vault was impossible in a decentralized way. But BitVM showed that you could have sort of like an optimistic game that you run on Bitcoin. And
Okay.
as long as one honest person is observing or operating in that model, then it's secure. And that was a eureka moment. So BitVM 2 was the ZK version of that, where
Okay.
you're doing a ZK proof instead of doing like a huge amount of transactions. And BitVM 3 is something called garble circuits, which optimize even further 10,000 times. And that just got released a couple of days ago, maybe today or yesterday.
Wow.
And that is like the next generation of that, which makes it even cheaper. So you could potentially, have much lower liquidity requirements. More people can join. It's becoming viable to operate this at a massive scale. How you use those technologies is different for everybody because there's a whole bunch of people doing roll-ups where they're using Bitcoin as the data availability layer as well. They're
Yeah.
trying to maximize the Bitcoin blocks to make it maximally decentralized. You still have the one event trust assumption in there, right? Um, while others are using it and storing data elsewhere. So those systems are trust assumptions are where you're storing the data. And we are saying, okay, yeah, we're creating an alternate system, but we're merge mined already. So we're kind of tied at the hip with Bitcoin in a little bit more meaningful way that allows us to effectively, we released the white paper at BTC Vegas. So a couple weeks, a month ago now, or
Okay.
few weeks ago. And we prove in our paper that you could get equivalent security to that of a native sort of solution on Bitcoin. Like some of these people that are actually storing everything on Bitcoin,
Yeah.
they still operate under a one event assumption. We prove that we can get that same level of security, but you're doing it through the side chain, which is another eureka moment to us.
So
because
nasty, right?
Now you have all the flexibility of another custom ledger you can design to whatever taste you want, scale it up. And the way we see it is you'd have to tweak it the way we tweaked it to get to actually hook it into Bitcoin in the proper way. For example, if you just do another DA based on KZG commitments, like what Ethereum did, right?
Yep.
First of all, you have to do proof of stake. Why? Because if you're doing something, the KZG commitments are like, I say we are two nodes in this blockchain, right?
Yep.
And a data blob comes in for a rollup. You get half and I get half. And then a checksum gets created. It gets a little bit bigger than, it's like 1.5 times size. The real, it's 1 megabyte, so it'll be 1.5 megabytes, something like that. You store
Okay.
750, I store 750. And we both sort of give a proof that I know that the data exists. And if I give a proof and someone challenges me and I don't have the data, I get slashed. That's the proof of stake model, right?
Yeah.
With slashing. While in proof of work, you can't do that. So you can't do traditional DA, first of all, on proof of work. So if you're
And
creating
no
a side
slashing, right?
you need slashing, which means you're dominant on proof of stake. And for us, we're like, can we do it with proof of work? And the way you do it is you just create a hash-based DA. So every node gets the data, they rehash the data, they check to see that the hash is correct, and then they process the hash. In the proof of stake model, you get the KZG commitment, you do a cryptographic operation on the commitment, you verify it really quickly, and then you just store the hash. So the hash part is the same, but how you verify it is different. And the hash, because it's just hash, we are not only quantum resistant, we don't have the trusted setup, it's much faster, it's more aligned with Bitcoin, you can get away with proof of work, and all of these little tweaks that we had to do that no one's done, because we thought about this separately than looking at Ethereum. We took the ideas from Ethereum, but we completely independently came up with solutions. So we weren't biased and we're like, oh, we have to do KZG commitments. No, we were like, we want to solve the problem in a Bitcoin friendly way. So, okay, here's a way to solve the problem. Let's run with this. Let's do hash based. So if you don't do those tweaks, you end up in an inferior solution where you're dominant back to proof of stake. So what's the point of bringing your Bitcoin and calling a scaling solution if you're going to be proof of stake? You might as well just use those solutions that are going to be native to Bitcoin at that point, because you have that one event security model. So
now you just spit off so much information. I gotta run it back on you there. For your solution, bringing it to Bitcoin rather than having a staking solution, how do you verify without the slashing? That'd be the first thing. And then quantum resistance. You mentioned Syscoin's quantum resistant.
No, well, I mean, even Vitalik was saying we need to redo the KZG stuff in Ethereum because we need to have quantum resistant hash signature functions all built in now in the next few years.
Right.
I think Ethereum will be updating. Bitcoin, I think Taproot is a little bit better, but there might be other signature schemes that will be put in that allow people to upgrade. What we do with Satoshi's coins, I'm not sure. We'll figure that out. But we already use change addresses by default in Syscoin. All the wallets are using change addresses. Change addresses are just hash functions, so they're safe, right? And that's why it was designed to use change addresses. As soon as you have a UTXO model, you have this beautiful benefit of being able to rehash the next state. And so the person that has the funds, they just store their public key. That's their sort of like private protection. It's still a protected variable, but it's like even if it gets exposed, you're still safe, but you're not quantum safe because the public key is directly linked to the curve, whereas a hash isn't. Hash is sort of one way, sort of secret, and everything in Syscoin and Bitcoin are protected that way, except the old style addresses. In Ethereum, everyone uses accounts and then they rehash. The public key, the addresses are reused frequently because I was telling you it's like a bank account. And when
Yep.
you reuse the same address, you expose those keys. So the wallets and all that stuff will leave them exposed. The KZG commitments are the DA solution. It's separate from a blockchain. The DA solution uses something that's it's not friendly with at all against quantum, and we just use catch a cache, and it's safe as like the hash functions that you would just store your coins in.
Yeah.
And the drawback there is it's not abundant as a sampling system like not the one Ethereum has, but maybe Celestia or some of these other ones.
Yeah.
It's not as abundant, but we say you don't. If you're going to try to get to that level of abundance, you're going to have to make trade-offs, and those trade-offs are the fact that you have to use this cryptographic mechanism and sampling. You have to trust someone else. It's not going to be like Bitcoin. While we're like, we don't want to make those trade-offs. Let's see how good we can get. And then let's stop there and say, this is the amount of data we can provide before things start to break and become centralized. And that's what we're all about. And we're trying to we're not trying to make the trade-offs. We're just getting to the limits of what you can do. And that's why I was saying, again, like if you tweak any of this, it becomes an inferior product. You have to do it the way we thought about it, we think. Because if you tweak any of the variables, it breaks. It becomes something else. It becomes proof of stake.
You introduce vulnerabilities, right?
Yeah. You were asking how do you secure
how do you verify?
Yeah, how do you verify
without the slashing on the
Yeah.
network?
So if you don't have proof of stake, you have proof of work, then you have you're going down a different path where every node is verifying everything. And you do need finality though, because if you have data availability, it means you are deleting data off of the nodes in the blockchain, right? And that means what happens if you can roll back, like for example, say that the data is removed after 6 hours,
Yeah.
but then the blockchain does roll back more than 6 hours. How will the nodes reconstruct state if they don't have the data? They'll say,
Yeah,
I don't
that'd be
know,
crazy,
I don't have the
right.
data, I'm stuck,
Yeah.
right? So to prevent that stalling, you have to have finality. So what you do is, if you once you have finality, you can remove the data after finality because you know it won't roll back. It's going to be final. But how do you do finality without going back to proof of stake? And we solved that through Sentry nodes by simply just having the Sentry nodes vote for what is the latest blocks they see. And when they come up with a consensus, they create something called a Chainlock. And in that Chainlock, you basically say, okay, everyone agrees this is the state. It's 6 hours old, 6 hours plus. Let's
Yeah.
lock there. But if they can't agree, let's go back to the longest chain rule of Bitcoin proof of work and fall back to that. So that's how we stay proof of work, yet optimistically allow the finality to happen through chain locking. And that allows our DA to happen. It also solves another problem with merge mining, where the merge miners in 2013, Luke Dax Jr., he broke merge mining from a coin called Coiled Coin in a famous experiment to try to prove that merge mining won't work. And he doesn't like altcoins, right? So he's like, no, this coin is stupid. Like I'm just gonna mine empty blocks until it dies. And he was able to do that, but it didn't die. It just proved that it was vulnerable, because what happened was he owned more than 50% of the mining hash rate, mining his coin, and he basically just kept overriding the blocks and keep repeating with empty blocks to make it unusable. That's called selfish mining. And he private mined and selfish mined to try to kill it. If you have a roll up and you have real money on the system, and then the miners are rolling back stuff all the time, and you can't use a system like that.
Right.
Even if it
Ain't
costs
no
real
way,
money,
right.
you can't depend on that. Imagine a roll up that's doing 2-second blocks, and all of a sudden has to roll back thousands of blocks. The finality solves that, and once you're final, the Bitcoin miners can't do anything. They can't roll back the state of Syscoin, no matter how much
Okay.
hash rate they have. So that's another benefit.
I was thinking about the slashing on other networks, and how their vulnerabilities come into play when they don't verify certain blocks in time, and then they get
Mm.
slashed because their node goes down,
False
things like
positives,
that.
false positives. Yeah, you can
Yeah.
like we were talking about offline, civil attacks and these sort of things where you can pretend to be other people and then you go and spam the network to get everyone punished.
Yeah.
We believe, just like you're raising a child, you don't negatively reinforce, you positively reinforce.
Yeah.
So we have a seniority model where we pay more to these Sentry nodes if they are honest and they're working. They just get paid more over
That's
time.
cool.
It maxes out, just like a real job, right? Like you
Yeah.
get seniority, and as you get seniority, you make more compared to everyone else. It still deflates, but you're still relationally you're making more than everyone else. If you have slashing, you're negatively reinforcing. So sometimes you give the child trouble when he doesn't deserve it because you don't know the full story as a parent, right?
That's happened, right?
And that might change the child's life, right? Because he
Yeah.
might be really bad. And negative reinforcement has been proven to be inferior to positive. You apply those philosophies and say, well, if you're going to do negative reinforcement, first of all, it has to be proof of stake. You don't do that on proof of work. You do that on proof of stake. And since we're proof of work, we thought of positive reinforcement. So you reward good nodes instead of slash them. If you um, with proof of work, you've solved the Sybil problem because it takes real work to try to screw something up. And
Yeah.
with the finality, you can't get beyond
A
the
certain point.
a certain point, so you stop sort of both problems. Within that boundary, you could override stuff, but proof of work protects you from that, and that's Bitcoin difficult proof of work, not just any proof of work. It takes like only the Bitcoin miners can really do that.
No, okay. Now, the next angle I want to cover is ZK-SYS in the testnet. Is that open for testing now, or is it something that's coming soon?
Yeah, we launched that sort of on testnet, and then we did another upgrade to the latest version, which includes Gateway, our Bitcoin Plus gateway that allows, first of all, like why ZK, right? Like why not just optimistic? There's wonderful teams building uh, their awesome roll-ups and optimistics, and people are actually thinking the optimistic still has a place, and it does for certain things like gaming and simulations and other things where you need a little bit more scale. ZK is not there. Optimistic is great for that. You can prove a whole Linux virtual machine in optimistic rollup, so you can't do in ZK, and run any program you want on your computer and make it provable that it's deterministic. It has to run this way. Like
Wow.
imagine cloud computing that has to run exactly the way, like imagine you have AI running in the cloud and you want to know exactly that it's doing the right thing and giving the right
Yeah.
output. You can do that with the optimistic model. And ZK is not there yet, but it will get there one day, just not today. But ZK
Okay.
is these other benefits, right? Like for a settlement system, ZK makes a lot of sense because the problem we saw with rollups and what Solana guys latched onto was liquidity fragmentation, right? Like you have all these rollups and different apps and dApps and DEXs, and they don't share liquidity, right?
Yeah.
And what Polygon and what our ZK Sync Matter Labs trying to do is they're trying to create these common layers, and you can only do this with ZK, where you do ZK proofs of these edges and you combine them and you can send messages across. And optimistic, it's much harder to do that because you have these 7-day delays, and within 7 days you can screw around
Is that
and
where the edge chains comes into play
yeah,
for Syscoin?
yeah, like edge computing. You're doing stuff on the edge, but you can do it in a way that's you can combine. It's composable across other edge chains. So you can have a one chain that's doing something specific, and it could share liquidity or share messages and DEX transactions with another. That's the idea because they have a common ZK gateway that allows the proofs to be combined and
Come into the same. Yep, I
yeah,
got
and
you.
it all gets crunched into one proof at the end. The only thing that gets more and more expensive is the data availability because as more transactions happen, more data gets used up, but the gateway will also crunch all of the data. So if there was Tom that was doing 15 transactions across 10 different edge chains, then he will just have one entry. He doesn't need 10. And
Right.
like a normal system, you would need 10 separate updates, and every transaction has to go in an optimistic role. Every transaction has to go in the DA layer. With
Yep.
ZK, you can say, I just want to know the difference of after those million transactions you did. I just need to know what the final balance is and store
Yeah,
that.
that's
It's much
way
more.
nasty. Yeah.
Yeah.
Saves so much data on the
Yeah.
crossover
And
too.
that's how you scale, right? The bits and bytes matters. That's how you scale. And you create this composable experience. Then you create a settlement layer that allows you to share and allows you to expand horizontally and put your computation on the edge to scale on the edge. And you run your optimistic systems there on top that need more scale. But if you want to benefit from all the shared liquidity and dApps that are cross-linking each other, that's ZK.
Okay, now is zkSYS available now or is it still in testnet?
Testnet entering, we actually deployed the contracts to mainnet recently because there was an opcode in Ethereum that got enabled, and we needed to work around that because
Okay.
the smart contracts needed that opcode, but we had to come up with a different solution. So we figured that out, launched that, and yeah, the great thing is the gateway stuff is in there. Um, zkSYS is the first edge chain, right? It's not going to be the only one. It'll be the first one, and think of, I guess, Rollux settling directly on EVM, but zkSYS would be like there'd be gateway, and then zkSYS is the edge chain settling to the gateway, and the gateway settling to Syscoin. So
That was the next question. So when you look at the overall scope of Syscoin, when you try to place the different levels for whether it's scalability or the security or tying back into Bitcoin, what are the layers? If you could label them 1 through 4, what would be like the main layer down to the lowest layer right now?
yeah, most users they never touch the base layers, right? Like
Okay.
you in a home, you're not touching the all of it, like little bits of the
The
electricity and
plumbing
the
or
step
the
down transformer
wiring.
and the
Yep.
plumbing. It's all convenient, and you're just using it. And that way that you'd be on the edges. And
Yep.
you start with Bitcoin, the miners, and emerge mining. You have this really secure vault bridge that has awareness of merge mining and ZK, all that stuff built in that we did. We released the paper there. Then you have Syscoin, which hooks into this experience where you can customize a modular stack for Bitcoin coming in and other assets, but Bitcoin would be like the most decentralized external asset coming in aside from
Okay.
Syscoin. You can have stable coins on there, obviously, but that's trusting Circle and Tether. But if you want to have
But
decentralization,
you can bring Bitcoin from the main chain onto
that would
Syscoin.
be yeah, that would be the idea. Is you bring it into the EVM and then onto the edges, and then
Okay.
you put it to work, like fractional Bitcoin based stable coins or AVS DAOs that you collateralize with Bitcoin, lending, borrowing, all that stuff.
So nasty.
We let other people figure that out. I mean, we just want to build the infrastructure and maybe
Infrastructure.
a
Yep.
couple of use cases that might be interesting from SysLab side, but that build we figure out the most secure way to do that, and then you have obviously the two chains in Syscoin on the UTXO side, EVM. The data availability is on the UTXO side, the virtual machine, where all the smart contracts are on the NEVM. You have the zkSYS system running on top.
Oh,
We
so
call it
they run parallel basically?
yeah. The virtual EVM and UTXO are parallel. It's like they're one and one. So
Yep.
when you create a block, you have to create both,
Okay.
and you combine the transactions separately, but they're running separate processes. Very much like the beacon chain in Ethereum. You
Yep.
have a separate chain, and then you have the execution layer and the consensus layer. Very similar. Consensus layer is the UTXO chain, and the execution is the EVM running
EVM.
Geth.
Yep.
Yeah. So, and then you have the Bitcoin plus zkSYS stack that's launched on top. You would never touch the gateway. It's just like an intermediate layer. You just say where I want to go. Like I want to go to zkSYS or I want to go somewhere else, and
Yeah.
you go there and deposit and withdraw. And gateway is sort of hidden underneath, as plumbing, you would say.
That's so crazy. Now, another thing, you guys have an official wallet. Is it Pali or
Poly
Pali?
wallet. Yep.
Pali, okay. Will the Pali wallet support Bitcoin on Syscoin?
Yeah, yeah. I'm actually doing vibe coding on that right now and restructuring it and you know really making it dynamic. Bitcoin, all EVM chains, all UTXO chains, ledger support, hardware, Trezor support, imported accounts and seed phrase accounts. Uh, all the descriptor stuff probably do. So it's going to have like full support. I don't think any wallet like that exists. Like even MetaMask doesn't have native UTXO. You have to do an extension.
Yeah.
And the extension's not native to it. Like there's a whole bunch of problems where you need native support. You're switching accounts. Like you can't have you have one seed phrase and then switching all those accounts, and you end up having different problems. We
Right.
solved that in a very generic way. So your accounts are segregated, but you have one experience and one seed phrase sort of doing it all. And to keep things secure, we don't store your passwords even in memory. We only keep the hash salts and hashes in memory. So like security first principles, and it's open source, so people can review it with their smart models to try to find it how they can break it and make sure that it's like super secure. There is no open source wallet that supports both that does things in the right way. Like for example, using change
Okay.
addresses. We use change addresses by default. Like you can't in the when you send a transaction, you can't actually set change to yourself. It has to be going to a change address for security, like just for these reasons.
Yeah.
And but your experience looks and feels like a normal account. Like it will just balance will just keep showing up. Your address where your funds are stored will be different, but you won't even know or care. So that experience is built, and it'll be consistent between virtual machine, Bitcoin. We also have the asset layer that's sitting on Syscoin called SBTs, and that's really useful for Bitcoin because you could do atomic swaps from Bitcoin into this asset layer. Because you
That's
can't
cool.
remember, I was saying UTXO has some benefits. You
Yeah.
can do really, really secure atomic swaps between UTXO chains. So you would actually, if you don't want to do the slow bridging process, you could just find a partner to swap with, swap it into SPT, and go over the bridge to the virtual machine and to the EVM land and go into your edge. And that's fully
That's cool.
decentralized. There is no middleman. It's just finding someone to swap with. And
Okay.
that would be like the efficient way if you have someone and that you want to pay a premium for it.
Yeah.
You can go in really quickly and out really quickly.
That's cool. Now, to close out the interview today, is there anything else that you want to highlight about Syscoin for the next 6 months or the next year, what they can look out for?
Yeah, I think velocity is increasing because of these AI tools. Um, all across all of the devs working on it, we're speeding them up on basically using Copilot and Cursor. And I think, for example, Pali, I rebuilt the whole thing in about 2 weeks from the ground up. It was a multi-year project, and
So
this sort
let
of
me
thing
stop
is
you there. Are you the lead developer on that as well?
I wasn't, but I sort of took
He said,
over
I am now.
because you want to make like if like you're saying Poly's the home, and so you need
Yep.
to have a secure secure desktop sort of experience, and that will be like all over the stack, right? Like for Syscoin and for the bridge, it's things are just going to get faster and more secure. I almost feel like software is going to become a commodity. It's commoditized, so it's not actually a skill. It would be like table stakes. If you need code done, it will just be done. Like you just say, I need something done, and it's done. And it'll be like machine code secure, like not even a byte will be off.
That'd be
And I
sick.
think
Yep.
that's happening really quickly. So what is all these ideas out there, which ones are safe, which ones have value. Like, why would, because a kid in Africa can compete with Silicon Valley, a 20-year-old vet now, and how do you know which one's good, which one's not good?
Right.
Because software is a commodity. Like, it'll just be, um, what actually matters is probably the value we're creating. Decentralization cannot be replaced by AI. The block hash in Bitcoin cannot be replaced by AI, and the connections and the mechanisms to build all them together cannot be really replaced, because those are network effects. That takes, there's actually financial rewards and incentives breaking it, not breaking that cannot be really replaced. The applications and all these cool ideas on top, those all can be replaced, and they will be built at really high speeds, by kids that just use these tools, I think.
All right. Now, one last question to close out the interview. When you think about the intersection of AI and blockchain, what are the top 3 use cases you could see for AI tying into blockchain technology?
I think early on it was like, how do I know that? How do we solve, making sure that the AI doesn't take control out of us, and you have inference,
That's always
like
going to
all of
be a
that, like you
question,
had the
right?
singularity net and that sort of thing. I don't think that makes sense, because as much as you try, like, you are going to be the mouse in the trap at some point. But there's things that are useful that make a lot of sense. For example, you have a higher intelligence, it's going to be able to make better decisions. So financial modeling and stuff. So if you wrap that into a DAO, you have a financial tool that allows people to invest. It's going to make more money, outperform anyone else. Um, how to get into that would be smart contracts using DAOs, right? You can't
Yeah.
really do that outside of that. So that's an interesting use case. Um, One of the other cool things we're working on is AI driven consensus models, like, with EigenLayer. Um, we When I saw EigenLayer, I knew right away that AI consensus on top of that is where it's going. I think that's where they're transforming now with the cloud. But an AI based consensus where, like, one of the use cases we're looking at is insurance, right? Insurance is for any insurance, for like your Walmart, you want to
Okay.
be insured. You want to do fast transactions. I want to be ensured that my coffee is going to be covered, or the merchandise will be covered for real time
Yeah.
transactions. Insurance cuts down all the middleman costs because it's on the blockchain. But you have the AI agents all deciding, yeah, a claim is good or not good because they have the data. And humans can step in there, but it's just streamlining the voting process. It's just making sure that you have someone smart as you or more making the decision for me. I don't have to be there. It's going to be 24 hours a day deciding for me. If it's contentious, I step in. If not, AI can do it. And you can almost do anything with consensus. You can build anything, but insurance, a DAO, financial assets is really interesting. And then finally, I think it's not per se an intersection, but it's how we think of Web3. I think Web3 is an incentive vehicle. It's a vehicle to have people come together, and like
Yeah.
like you're saying, Cato and all these other ones. It's an incentive vehicle to get people together. Now, when people are together, um, usually you're talking to, you're setting up meetings, and you're innovating, right? Innovation
Yeah.
is going to be just, how do I talk to the LLM, and how do I produce? Now that's innovation, right?
Yeah.
Actually, people are getting dumber as a result, but like,
Yeah, no, that's another thing I'm experiencing now, looking across the industry as a whole, is you see people pushing this is how you build better prompts, and you see videos on YouTube and TikTok about that, and it's like, man, if somebody's using an AI model, they should know how to write a prompt. But then
I
you
think,
have
yeah, I
people
think
from older
prompting,
generations
yeah,
that don't understand it, that need the training. So it's just
yeah,
wild to see that as a new avenue for people to fill in.
yeah, exactly. I think I'm not sure you need to be a prompt expert anymore, because they actually work better if you just say what you need. The thinking models, at least like
Yeah.
DeepSeek and like Opus and Sonnet, are really good. Just you say what you need. But if Web3 is an incentive vehicle, and AI is this solution provider, then combining them would be awesome, because you can get people together and then you use the tooling to build. And that's almost like you would say, like maybe that's like a WhatsApp or a Telegram, where you have people coming together and pay through Web3 incentive rewards. And then, since they're together, they can just prompt the AI and use media and meetings and AI-driven tools to create. Right now, every single person is just talking to AI themselves, but there's no shared collab to solve the problems, and that's another use case that we're looking at to solve.
That's wild to think about when you think about you incentivize the people to come together, but then you want them to build. And when you do combine the two together, how do you incentivize people to build? That's the next question we need to solve.
Yeah. I mean, because then you're questioning what value really is, right? Because when everyone is building, how do you value, because everyone's going at breakneck speed, creating like billion-dollar ideas in minutes. How do you value one versus the other? It's basically, it's all just random entropy, right? At the end, because in the end, consumers are not going to consume at that velocity, right?
Right. There's going to be way more than what people can consume.
So we're slow, and since we are driving that value through monetary expenditure, we just can't move fast enough. And so there'll be all sorts of cool things, and nothing's going to be a unicorn. Everything's just going to be replaced by the next thing the next day. And so it ends up being that you are coming together to be maximally truth seeking at the end. It's just ends up being like a church almost, but it will start like, I will create cool concepts, cool ideas. We all make money. The people that get together and create groups that are worthwhile, people want to get in, so they'll pay. There'll be ways to monetize information. That's all Web3, right? And combining that, it'll end up being that we are all here and we're looking to just share ideas and look for truth. And that's where it ends up going long term. But I think in the short term, there's definitely demand to innovate together, because everyone's innovating in silos right now.
It's mind blowing. Well, I appreciate you being here today. This has been Syscoin, the ZK bridge for Bitcoin. Thank you for being here, brother.
Thanks for having me.
The Crypto News Podcast with your host, Joshua Roomsberg. Follow and subscribe today.